In this problem, we are not told what the population standard deviation is, but we are told that the population variances are equal. So going to get more help and pulling up the textbook takes us to 8.2. And on this next page here, 429, there's this flow chart. And we don't know the population standard deviation, so no. And then so we can answer this problem, we're assuming the populations are normal, so yes. Are the population variances equal? And this problem said yes. So we have to use this complex calculation here to get the t statistic. And I don't think it's listed on this page. You actually need to go back to the previous page to see how to calculate that. So coming back to the 428 here, the beginning, we need to figure out this right here. Let me move that to the side. I'm just going to pull it up here. So on top, we need the number in our first sample. So there's 1, 2, 3, 4, 5, 6, 7. So 7 minus 1 would be 6. So that's going to be 6. And we need to multiply that by the variance here. So the standard deviation squared, which is the variance of this sample size. So let me get that going here. 6 times variance of our sample. And this is our sample. All right, so that's just that first part of the formula. Over here, the number in the second, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 of them. And 1 minus that would be 9. So 9 multiplied by the variance of this sample. So I have those two values that are going to be added together on the top. And then on the bottom, I'm going to add the two sample sizes together and subtract 2. So we had 7 plus 10 is 17, and subtract 2. Let me just write that out here. We had 7 plus 10 and then minus 2. So you're going to get 15 for the number on bottom. And I want the square root of that entire thing. So I've really broken it down to chunks here. But this is going to be the final calculation. We have the square root. And on top, I should probably put that in parentheses for the top, this number plus this number. And then divide by the two sample sizes added together, minus 2. So that is this calculation here. And now I need to actually multiply that by the square root of this right here. So one more step here. So the square root of 1 divided by 7, 1 over the first sample size, plus 1 divided by 10, 1 over the second sample size. All right, and it says to take our previous calculation we did and just multiply by that square root. And so I'm going to come down here. Let's make it clear this is my final answer here. I'm taking that first big calculation and multiplying it by that square root to get my result. So that wasn't the test statistic, that was just the standard error here. And there's two different ways to calculate it. We calculated it the way I just showed because of equal population variance. So coming down here to actually calculate the test statistic that we need, that's the part we divide by, that value we just did. On top, we're going to subtract the sample means from each other. So let's do that. On top equals average. So the first sample mean, and then subtract the second sample mean. You know, I actually like to see those numbers. Let's just see what that first one was. And then let's find the average of the second one. I think it's nice to see how far apart they are to start with. So it looks like they're just a couple, 2 units apart here. So we're going to do that subtraction here. Subtract the sample means from each other on top. And then we're dividing by that standard error that we calculated here. And we got our final result then. This is our test statistic. And just to clarify, in case there's any question, this part of the calculation is 0. just based on our assumptions, what we're trying to check is if those population means are equal. That was the null. And so subtracting those values away from each other, since we're assuming they're equal, is 0. So we're just subtracting the sample means on top and then divide by that standard error that we calculate.